And I continue. And I continue. And here we are. Paul's notes. All right. I think he's called Paul Dawkins, I believe that's his name. Anyway, these are beautiful problems. So, but why is that? Why is that not working? Hold on, 1 second here. And Max, a new page. All right, so as we were, problem 7. Solve this. Solve using what technique, you ask? By completing the square. Okay. 4u squared take 8u plus 5 equals 0. Bring out 4. We'll have u squared minus 2u. I'm going to move that 5 over to the other side, actually. And now complete the square in the usual way. Just like that. Now, if I expand it, I recover u squared take 8u plus 4. So I need to take away 4 to balance the books. Just like that. So I'll get 4u take 1 all squared equals -1. So u is equal to 1 plus or minus a half I believe. Next up, problem 8. Isn't that great? So, yeah, I'm going to divide everything through by 2. Personally, that's what I'm going to do. So I'm going to have x squared at 5 over 2x equals -3 over 2. Thank you very much. And then I shall complete the square. So I get x plus 5 over 4 all squared. And I want to take away 25 over 16, just like that. And then I want to add it on to 3 over 2. Well, 3 over 2, -3 over 2. Well, -3 over 2 is the same thing as -24 over 16. So it becomes 1 over 16. So it becomes x equals -5 over 4 plus or minus the square root of 1 over 16, which is 1 over 4. Which is -1.5 or -1. So it seems. And now we check. Hold on. Is this right? So we apply the discriminant here, b squared minus 4ac. So we have 64 minus 80, which is a negative number. So we expect imaginary answers. And it looks like that's correct. And that's great. That's good. And here we have, yes, that's correct as well. Now for the next set of problems, we need to apply the quadratic formula. Which is as follows. So when I apply it to the 9th one, what will I get? Well, I'll get that x is 6 plus or minus the square root of b squared, well, that's 36, minus 4ac, well, that's 16, so 20, all over 2, just like that. So that's root 20 is 2 root 5. So it's going to be 3 plus or minus root 5. Just like that. And now let's move everything over to the left-hand side in our minds. So W is 6 plus or minus b squared, which is 36, minus 4 times 9 times negative 101, which is plus. So 909 times by 4 is 3,636. And all of that has to be divided by 18. Now we get 3672, which is 36 times 102, which is the same as 4 times 26. Okay, so what? So what, 12? 12 times root 26. 6 plus or minus this, which is cancelling down by 3. 1/6. Wait, hold on. Are you kidding me? That's 1/3 plus or minus 2/3 of root 26, I believe. And now comes the 11th problem, the 11th one. So all on one side now, please. So 12u right there, and 65 right there, and solve. So u is minus 12 plus or minus the square root of 144 minus 4 times 8 times 65. So 4 times 65 is 260, and times that by 8. We get 2080. And it's all over 16. But hold on, 144 minus 2080, that's negative. Yes, it is. So what is it though? Calculate. All right. 1936. Negative 1936. Now I recognize that that is a square number, is it not? It is, isn't it? What is it the square of though? The answer is 44. So it's going to be minus 12 plus or minus 44i all over 16. And clean that up. Minus 3/4 plus or minus 11 over 4 I. and check your answers. Check your answers. Good. And you know, they could have gone wait, 102. Oh no, I thought it was 104. Oh, calamity of calamities. All right, so I must fix this. It is very important to be accurate. 3,672 would be there, which is 102. So yes, indeed, that's not actually. There we go. Better. Accurate. And accurate. Good. Now problem 12. 4t squared minus 20t plus 169 equals 0. So t is 20 plus or minus 400 minus 4 times 4 times 169. So that would be 52 squared, wouldn't it? Which is 2,704. But that has to be subtracted, you know. All right, fine. And all of that is divided by 8. So what is 400 minus 2,704? The answer is 2,304. Negative 2,304. And is that a square? The answer is yes. It's the square of 48. 48. So it would be t equals 20 plus or minus 48i all over 8, which is what? 5 over 2 plus or minus 6i. Next problem. Z squared plus 3z minus 130 equals 0. Now we know ahead of time that this is how you can get the solution by factoring. But we must check by the QF, the quadratic formula. So minus 3 plus or minus, we must say z equals first, minus 3 plus or minus the square root of b squared, which is 9, minus 4ac. So it's going to turn into a plus. And 4 times 130 is 520. And all of that is divided by 2. So it's equal to, that's 529, whose square root is 23, minus 3 plus or minus 23 all over 2, which is 10. Hold on just a minute now. Just a minute now. Minus 13 or 10? Uh-oh. What a calamity. They disagree by signs. Okay, did I do this wrong? One of them must be wrong. Oh, I get it. The signs are the wrong way round. You see the benefit of having two methods? They check one another. So that's a plus, that's a minus. And so that will be a plus, and that will be a minus. And we check. We check everything. We always check. Problem 12. Okay. Hold on. Is that right? Oh, that's for that one. And I'm pretty sure I already checked 11. Okay, that's accurate. And that is accurate as well. And finally, so is that. Indeed, I agree with your final comment, Paul. Okay, so that completes that set. But we're not done. We have to look at this now. A summary of quadratic equations. So title the document Quadratic Equations. Summary. And solve. Use the discriminant to determine the types of roots for the equation and do not find any roots. Very well. The discriminant, symbolized by delta, is b squared minus 4ac. In the general form of the quadratic equation, which goes ax squared plus bx plus c equals 0. And so we will apply that to this first quadratic. So it is negative 182 squared minus 4 times 169 times 49. Okay, so that can be done. What is negative 182 squared? Three, three, 1, 2, 4. What is 169 times 49 times 4? Three, three, what's that? Try again. Three, three, 1, 2, 4. What? Oh, right. Of course, they are the same. Okay, so the discriminant gives us 0. Therefore, one repeating root. One repeating real root, if you like. It doesn't tell us what that root is, but it does assist. And now to this one. B squared minus 4 times 1 times 61. 28 squared is 784. 4 times 61 is 244. Subtract, and you get 40. Therefore, two real roots, which are not integers, but not wait, how do I put this? But involving surds or radicals. That sounds good. Because 40 is not a perfect square. And now b squared minus 4ac has applied to this. What is 126 squared? $15876. What is 49 times 102, and then times that by 4? That would be 4998, and timesing that by 4 gives 8 less than 20,000, which is 19,992. And now subtract. Okay, so that is well, 4,116, but negative. And is that a square? No, it's not. So two complex conjugate roots. How about that? With surds. And last, b squared is 0 squared. Subtract 4 times 9 times 151. So 4 times 9 times 151. 9 times 151 is 1359. Doubled is 2718. And doubled again is 5436. So negative 5436. But is that a square? 74 squared is a candidate, but we try that. No, that doesn't work. That's not a square. So, as above. And now we check. We check everything. Okay, they call it a double root, but we call it a repeating root. But that's fine. Two real roots. Okay, we're in agreement. But we're in disagreement about this because this is wrong. And it's obviously wrong, and I can't believe that I didn't see that. So it must be corrected. And in fact, this first one has to be checked again. Okay, they did not compute it, but that's fine. But I should have done this one correctly. So anyway, 784 take away 244 is indeed 540. That's better. Okay, problem 3. Correct. And that is also correct. That is correct. Excellent. Excellent. Save. Okay. And now to apply quadratic forms. Now to apply. I am unsure what this will be like, but it's time to see. It's time to see. Applications of quadratic equations. The width of a rectangle is 1 meter less than twice the length. If the area of the rectangle is 100 meters squared, what are the dimensions of the rectangle? So the mental picture is this. It is a rectangle that seems to be wider than it is tall, but we don't officially know that. But just based on this verbiage here, it seems so. Let us call the length L. Let us call the width. Oh, I know what you're going to say. You're going to say W. No, I'm not. I'm going to say it's 2L minus 1 because I don't want to introduce more letters than necessary. Now, the area of the rectangle, well, that would be L multiplied by 2L minus 1, and that is equal to 100. So now expand, and we get 2L squared minus L minus 100 equals 0. And we can solve this however we like. I'm going to actually complete the square for this. So it's kind of like I'm reversing what I'm doing here. It's like I'm backing up in a car. Reverse time, Okay, and I'm going to divide both sides by 2 because I dislike having that 2 there. And now I'm also going to complete the square. So L take away a quarter. But then you must, because this generates 1/16 out of thin air, you have to take it away. And so I will add it on to the other side. So the length of the rectangle is 1/4 plus the square root of 50 and 1/16. We do not need to consider the negative square root because that doesn't make any physical sense. What is 50 times 16? The answer is 800. So 801 over 16. But we know that this is root 801 over 4. So it's 1 plus or minus root 801. Hold on a second, not plus or minus, just plus. Plus root 801. And all of that is divided by 4. But does that sound right? Does it sound right? Well, you can always just apply the discriminant to make sure that you're not going too far off the rails. So I'm going to do that. B squared in this case is 1. And we times that by 2 and by negative 100. And then we get 801. So it seems like that's right. That's the length. In what units? Meters. And now we want the width. So double that and subtract 1. But hold on a second. In the real world, you have to give approximations. Don't answer in square roots. And divide that by 4. So about 7.325. Okay, and now to get the width. So we must double that and subtract 1. And we get 13.65. But we must check everything. That is correct. And that is correct to a reasonable degree. Problem 2. Okay. 2 cars start out at the same spot. One car starts to drive north at 40 miles per hour. And 3 hours later, the second car starts driving to the east at 60 miles per hour. How long after the first car starts driving does it take for the 2 cars to be 500 miles apart? Very well. Very well. One car starts driving north at 40 miles per hour for 3 hours. So the north car is already 120 miles away from the origin. And the east car is, well, he's right there. And then they continue driving, actually. Okay, so what we want is an expression for the distance between them in terms of the amount of time that has passed. And then what I'm going to do is I'm going to add 3 at the end to account for the initial situation. So, because I just find it easier to mentalize it that way. Anyway, how to do this? The Pythagorean theorem, right? So this accounts for the east car. Yeah, that accounts for him. And what accounts for the north car? Well, it would be 120 plus 40t squared. And then you have to square root that and set it all equal to 500. So what I'm going to do is I'm going to set it equal to 500 squared. And now I shall expand on the left. You will forget to add 3, won't you? See if I can remember. Okay, and so it becomes what? 4,800? No, it does not. 9,600 T. Plus what? Plus 100 plus this. And that is equal to this. Okay, so a lot of zeros. Can I get rid of them, please? Divide everything by 100. You know? Okay, that's better. And now add these. And subtract 2,500 from 144. And we get 2,356 in the negative. Whoops. Okay. Hold on just a minute now. Can you not divide everything through by 4? Can't you? Yes, you can. So what's that? 24t. And what is that? 2,356 divided by 4. Okay, divided by 2 and then by 2 again. So don't back down. 1,100 and 78. And now divide that by 2. Okay. So 178 divided by 2 is 89. And then add that on. So negative 589. I believe. But I might be wrong. Wait, let me check. Okay, that sounds fine. And what now? What, can you factorize it? Well, I want to try it. I could use a formula, but, you know, you have to try. So b squared, that would be 576. And then this will be a plus. So 4 times 13 times 589. Are you kidding me? I'm not doing that. I'm not doing that. Okay. Well, can you factorize 589? Okay, I'll try. 3 does not go into it. What about 7? No, not 7. What about 11? Nope. 13. Yes, 13 does go into it. But how many times? I don't know. 43. Okay, so use that to your advantage. Wait, that's a semi-prime, isn't it? Isn't it? You're not going to get it this way, but why not? Just try. No, that's a complete disaster. That's not going to work. No ordering works. So it's time to use the formula. Okay, so, well, we tried. So minus 24 plus or minus b squared plus 4 times, okay, so 52 times 589 all over 26. Now, what makes logical sense? The minus sign, it does not. So eliminate that. And compute. Okay. Okay. $5.87. And you know what? I did remember to add 3. Time to verify or falsify. Either could happen. Oh, yay. Look at that. Look at that. It's accurate. Okay, so problem 3. Problem 3. Coming up after hydration. 2 people can paint a house in 14 hours. Okay. Working individually, one of the people takes 2 hours more than it takes the other to paint the house. How long would it take each person working individually to paint the house? Okay, I will call the first person A. And so what, you're going to call the second person B? No, I'm not. I have to figure out a way around that. Okay. I do not know how to do this. Yes, I do. So let's just say person 1 paints a house in T hours, right? And person 2 paints a house in T plus 2 hours. So speed-wise, this is the situation. For person 1, their speed is 1 house every T hours. And for person 2, their speed 1 over T plus 2. Agreed? Agreed. And now, so combined, they have this speed. One over T plus 1 over T plus 2. But wait a minute, you're not telling me how long they actually take to paint the house. The answer is 14. That's their speed, combined speed. So they take this long to paint 1 house. And that happens to be equal to 14, by the way. So now solve. Solve. Okay. Okay. Fine. Reciprocal both sides. And combine them. And flip and reciprocal. That's 2T plus 2. And now what? Now it's a quadratic, isn't it? So that's 28T. Subtract that, and you get negative 26T. And that is 28, and you subtract it, and you get negative 28. And that cannot be solved nicely. You have to use formula, don't you? So T is 20 plus or minus. I'll consider that in just a second. 676 minus. No, it'll be plus. It'll be plus. 4 times 1 times 28. all divided by 2. Okay, and what is the answer to this, please? Well, 56 doubled is 112, which is 788. 788, which is not a square. And 788 square rooted, I don't know. Well, it's about 28, isn't it? Okay, so what are you proposing here? I'm proposing that you have to add it on. $27.0356. All right, whatever. 27.0356 hours. That's for the fast guy. Fast person, whatever. And so 29.036 hours for the slow person. Let's see if that's right. A bunch of text. And correct. And that's good. That's correct, and that's good. Okay, so applications of quadratic equations finished. How about something new? How about equations reducible to quadratic form? Who are you? Oh, these ones. Okay, let's begin. Let's begin. Reducible or transformable? Quadratic in form? Problem 1. Notice that I could just replace x cubed with y. Then this becomes equivalent to solving y squared take 9y plus 8 equals 0, which is the following. So y would be equal to 8 or negative 1. But you're not allowed to say that because this is your own made-up variable. So you have to translate it back. So that means that x cubed is 8 or negative 1. And if x cubed is 8 or negative 1, then x is 2 or negative 1. Isn't that right? Okay, interesting. I shall let y equal x to the negative 2. How about that? then it becomes equivalent to solving y squared minus 7y minus 18 equals 0. Isn't that right? And can this be solved by a factorization? Yes, it can. Do y take 9 times y plus 2. So y is equal to 9 or negative 2. But hold on now, no one knows what you mean. So set x to the minus 2 equal to 9 or to negative 2. Now, what is x to the minus 2? That's 1 over x squared. And if 1 over x squared is 9, do you know what that means that x is? It means it's 1/3. Or negative 1/3, right? You didn't forget the negative, did you? Okay. And for this one, I'm perplexed. So I have to write it here. And I have to think. X squared is negative 1/2. Very well. Then x is that, which is unacceptable because it's not rationalized. So have root 2 over 2 instead. And we will check after the third problem. Okay, so what do I do? Oh, I know. Let y equal x to the 1/3. And then we have 4y squared plus 21y plus 27 is equal to 0. Isn't that right? And can you factorize this? Can you factorize it? Apply the discriminant, why not? So b squared minus 4ac, so 441 minus 16 times 27. What actually is 16 times 27? 432. So 421 take 432. Oh, no. That's a perfect square. So it actually is factorizable. So how do you do it? How do you do it? I don't know. Yes, I do. 4y there and y there. And add on 3 and add on 9. And that answers the question. So y now is negative 3/4 or negative 9. Now, did you forget about x to the 1/3? I did not. That is either this or this. Okay, so the cube root of something is negative 9. What is that something? The answer is negative 729. And the cube root of something is negative 3/4. What is that something? Negative 27 over 64. And now to check. Everything must be checked. Without checking, There is no computing or solving or calculating at all. So we spot an error. So time to fix that error. Okay, so this was not factorized correctly. So here it comes. That should be a negative there. And that's how we can recover this positive at the end. So that becomes plus, that becomes plus, and that becomes plus. You see, errors cascade throughout. So you must spot them and fix them and not make them. But I'm only human, you know. So anyway, for this one, okay, so that is valid, plus or minus a third. And plus or minus, do you see here how they did not rationalize the root 2? They see, but that's fine. That's fine. Some people like it like that. And all right, the next one. Okay, invalid, invalid, incorrect. All right, so it must be solved. It must be solved. Don't look, don't look. Just try to do it again. But accurate. Okay, fine. Okay, I'm almost certain about this step here. Okay. For factorizing, I'm pretty sure I did it right, but we will see. Right, okay, so the way to check is to expand. So 9y, 12y, that gets that, that gets that, and that gets that. So that's fine. So what's going on? Okay, so y is what? Based on this, negative 9 over 4. Or y is negative 3. And we're going to make the same mistake again. Okay. So I've got to cube this, do I not? Whoa, hold on. Excuse me. That should be an x. And that should be a negative 27. And now check. Correct. Good. Time to do more. Time to do more. You didn't think I was finished yet, did you? So let y equal x to the 4. Then it becomes the same as solving. Y squared takes 6y plus 7 equals 0. And factorize. Okay. This is going to be embarrassing if I get this wrong. So I'm not going to do it. So in fact, it actually can't be factorized. Right? B squared minus 4ac. That's 36 take 28, which is 8. So wrong. You cannot factorize it. But you can use the quadratic formula. So y is 6 plus or minus the square root of 36 minus 28, all divided by 2. That there is 8, whose square root is 2 root 2. So it becomes 6 plus or minus 2 root 2 over 2, which is 3 plus or minus root 2, is it not? And now, notice that I must claim this. Oh boy. Okay, so I have to take the fourth root of that. It doesn't exist. To my humble feeble brain. I couldn't get the fourth. No, I could get the fourth root of that, but it would take like 20 minutes. All right, how about this? So we decimalize. So 3 plus square root of 2 to the power of 0.25. 1.4495. 3 minus the square root of 2 to the same power is 1.1222. So now to check. Oh boy. Look. Correct. Good. Problem 5. Okay. This is actually the same, more or less, as the ones from before. So let's y equal x to the minus 2. Then we have 2y. No, do not let that happen. That's wrong. That is wrong. There. So we have 2y squared plus 17y plus 21 is equal to 0, which is factorizable. Okay, no, it's not. Wait, yes, it is. Yes, it is. Yes, it is. Did you see that? I caught the error before it happened. So y is -3/2 or -7. Consequently, x is the reciprocal of these. So -2/3 or -1/7. Right? Oh, yay. I did it. Okay. Problem 6. Problem 6. Hold on just a minute now. What the heck is this? Okay. Let y equal root x. How about that? No. Don't let that happen. Let it equal 1/root x. Then we are solving y squared. Take 11y plus 18 equals 0. And that's y minus 2 times y minus 9. So y is equal to 209. So you're telling me that 1/root x is 2, or 1/root x is 9. Okay, so x must be a quarter, or 1/81. Oh, look, a tiny, tiny spider. Okay, so check. Oh, we already have that open. Correct. Okay, so who's coming next? Equations with radicals. Let's see. Let's see. Okay, I'm very interested in you. Very interested. Time to solve. Equations with radicals, huh? All right. What do I do? Well, surely you just square both sides. Right? And then solve like an ordinary quadratic. Or maybe that's just a load of nonsense, and I'm about to be shown to be a nonsense spewer. So we must see. You know what? I have a feeling that this is just full of traps, but we're going to see. So what do I do? Well, b squared minus 4ac, of course. So 1 minus 4 times 4 times minus 3. That is 49, which is perfect, a perfect square, so factorizable. So here we go. Figure out how to do it. Oh boy. Do this. Okay, I did it. And now what? Well, take away 1 of that and add on 3 of that. Okay. So x is what? Negative 3 over 4 or 1? You know what? Check. Just simply check. Check everything. So first checking 1. 2 times 1, is that equal to the square root of 1 plus 3? True. Check negative 3/4 now. Is this true or not? Well, that there would be 2 1/4, which is 9 over 4, whose square root is 3 over 2. And this is negative 3 over 2. So I'm perplexed because you can evaluate it and get negative 3 over 2, right? So I'm going to do something in between a tick and a cross. I'm going to do a wavy sign with 2 little dots for like a confused face. And I'm going to check. Okay, we agree. Solve it like a quadratic. Okay. Has the unfortunate side effect of sometimes introducing values that are not solutions to the original equation. So to finish this, we need to look at that word, check. Check them. Okay. So in his world, the square root sign is it's a function and it forces a positive square root. Okay, so that confusion has been resolved. Problem 2. Okay. Square both sides again. Solve like a quadratic. Right? And x is -8 or 4. Okay. But check. Okay, 33 take away 8 is 25, whose square root is 5, and so 4 is valid. But -8 is not. As we may see or may not see. I don't know. It's time to find out. Okay, total agreement. All right, am I getting a little bit too lucky here? Take things for granted. So put x on the other side. Square it. And bring it over. Bring it over. And factorize. And solve. And check. Check everything. Check everything. 39 minus 30 is 9, whose square root is 3. 3 minus 10 is 13, which is not equal to 7. So invalid. (39 minus 3 is 36, whose square root is 6. And 6 minus 1 is 7, which is indeed equal to itself. So we check. I'm not going to be trapped on problem 5. I'm not going to allow it. Okay, that's correct. Problem 4, problem IV, if you like. So x minus 1 is, well, square it first and set it equal to 2x minus 2, and then expand it out. So x squared minus 2x plus 1 equals 2x minus 2, and move it over. So x squared minus 4x plus 3 is equal to 0. And factorize. Okay, 1 or 3. Check. Checking 1 first. 2 times 1 is 2, take away 2 is 0, and then we have the claim that 1 is equal to 1, which is true. Then 3. 2 times 3 is 6. Take away 2, that's 4. Square root that, that's 2. And 2 add 1 is indeed equal to 3. So it appears that we have a pair of truths. But did he trap me? No, he did not. He did not trap me. See, I know how it works. He's gonna try something here. Problem 5. Oh boy. Oh boy. It was like my worst nightmare. You know what? Just square both sides. Just do that just to start off with. Yeah. Anyway, you get 1 plus 2 lots of this plus this squared, which just, gives 1 minus x. Right? And now I have to square the other side, so I get just 2x plus 4. And now it's like I've turned it back into home territory. So I'm going to have the radical on the left. So that's 2 minus x, but I have to bring that over and do it with care. So 3x right there, and plus 2. And now divide everything by 2. And now square. Oh boy. Yeah, just do it. All right. So 1 minus x equals 9 over 4 x squared plus 3x plus 1. Quadruple everything if you really need to. If you're completely addicted to the integers, you can quadruple everything. But first I'm going to add x. And I'm going to take away 1. And I'm going to have that. So I'm going to have this. And I'm not, in fact, addicted to the integers because this is a very beautiful expression right here. So x is either 0 or negative 16 over 9. Now comes checking. So 0, in my estimation, is valid. Minus 16 over 9. Well, on the left, I will have 1 and 16 ninths, which is 25 over 9, whose square root is 5 over 3. So thank you very much. I get 1 and 5 thirds, which is 2 and 2 thirds on the left. And on the right, what is 2 multiplied by negative 16 over 9? The answer is negative 32 over 9. And add that on to 4. Okay. Negative 3 and 5 ninths. Added on to 4 is 4 over 9, whose square root is not 2 and 2 thirds. Whose square root is 2 over 3, but this is false. So I think that that's false, a false solution. But we'll see. We will see. Okay, we're in agreement. And that's all correct, and that's good. That's good. So equations with radicals is done. Although I really want to do these, I need to go and feed some animals, including my possibly. Be well, be well.